Hi there, in this video we're going to continue with identifying vertical asymptotes, horizontal asymptotes in behavior, and fully graphing a rational function. So let's start with the vertical asymptotes of something like this. So let's find the vertical asymptotes. I feel like those are usually the easier ones to find because the vertical asymptotes come from where the denominator is 0. So let's try to factor this as far as we can. So I want to factor x squared minus x minus 6 and see, essentially I want to know where the denominator is 0. So when the denominator of a rational function is 0. So we want it fully factored. So what number is multiplied in -6 and add up to -1? That'll be x minus 3 and x plus 2. Let's just factor the top as well so that when we're looking for intercepts it's easier. So I have 4x squared minus 4x, so it looks like the 4x is the GCF. So I'm left with x minus 1. So this is fully factored. So the vertical asymptotes come from a rational function when the denominator is 0. So I'm going to have, if the denominator is 0, when x minus 3 times x plus 2 is 0. So that means when x is equal to 3 or when x is equal to minus 2. So this should be looking very familiar because this is the same thing as finding the domain, right? The domain is all the values where the function is undefined. So a fraction is undefined when the denominator is 0. It just so turns out when the denominator is 0, those points of undefinedness are our vertical asymptotes. So those are vertical asymptotes, and you can check them too. So if I'm not sure, I'm looking at x equals 3 as a vertical asymptote. So you can do a table of values to see, well, what are the y values doing as x approaches 3, right? If I have y or x and y equals our function. So when x is equal to, let's say, 2.9, so what is y doing? And if x is equal to 3.1, so to the left of 3, and then to the right of 3, what are the y values doing? And so you can plug in into the function. So remember, our function was y equals 4x squared. Let me use the factor form. Y is equal to 4x times x minus 1 and x minus 3, x plus 2. So when you're looking at to the left of 3, so 2.9, so when you plug it in here, notice that you can have 4 times 2.9 times 2.9 minus 1. So these are all positive in the numerator over. Now you're going to have x minus 3, so 2.9 minus 3. Now that's going to be negative because 2.9 minus 3 is a negative number. And 2.9 plus 2, that's going to be positive. So when you do this, so put it in a calculator, and you're going to get, you get 22.04 in the numerator, and you get negative 0.49 in the denominator. So when you do this on your calculator, you're going to get negative 44.979. So about negative 45. So as x goes to 3 from the left, notice that the y values are going towards a negative high number. Right? If you do 2.99, 2.999, they're going to get even lower. So it's going to be going towards negative infinity. And to the right of 3, if you do the same thing, so you'll have 4 times 3.1, 3.1 minus 1. So notice that all of these are positive. Now, notice that you can have 3.1 minus 3. So now this is going to be positive times 3.1 plus 2. And this is going to be positive. So this whole thing is going to be a positive number. And when you do it on a calculator, you'll see that this essentially is going to be going to positive infinity. So the number that I got when I put it on my calculator is 51.06. So yeah, notice that it's going to be going towards positive infinity. So at 3, you're going to have a vertical asymptote, and you can do the same thing for -2. As you can do a table of values for this, choosing something to the left of -2, so like -2.01, and then something to the right of -2, like -1.99, and then seeing what your y values look like. But you should also see a positive and a negative infinity. So those are vertical asymptotes. So now, how do we find horizontal asymptotes? Those are a little bit harder because horizontal asymptotes are the end behavior of the graph. So as x goes to infinity and as x goes to negative infinity. And so that is a little bit hard to tell when the function is in this way. And even the factor form doesn't really tell us anything about the horizontal asymptotes. So horizontal asymptotes, we do long division of polynomials. So to find horizontal asymptotes, we're going to use long division. And this is why in the previous sections, it was important to know our long division. So let me write the problem down. So here's our original function without it being factored, and we want to perform the long division. So again, we have the numerator, the denominator. The denominator is the divisor, so I'm going to put that on the outside, so x squared minus x minus 6. And the numerator is our dividend, so that's going to go on the inside. So 4x squared minus 4x. I don't have a constant term, and I do have a constant term there, so I'm going to put a 0 as a placeholder. And so now we do the long division. So what do I multiply x squared by to get 4x squared? And that would be a 4. So I'm going to put 4 here. So notice that it goes all the way to my constant term. So that this is probably the only long division I'm going to have to do. So multiply it. So 4x squared. Remember, with long division, we want these to match up. Minus 4x. And what's that? Minus 24. And as usual with any division, we subtract. So when I subtract this, I distribute the signs, that becomes a negative, that becomes a plus, and this becomes a plus. So cancel, those cancel, 4x squared minus 4x squared, we cancel. Negative 4x plus 4x, those also cancel. So I'm just left with 24 as my remainder. And I say it's my remainder because now this is a constant term, which means the degree is 0. And the divisor has degree 2. Right? So as soon as we reach here a degree smaller than the divisor, we can stop. So that means that my y is equal to 4 plus the remainder over the divisor. 24 over x squared minus x minus 6. So why am I doing this? We want to know the end behavior as x goes to infinity or negative infinity. So notice that if I put in a really high number, so infinity means it's a concept, right? Infinity is not a number. Infinity is the concept something goes on forever on the positive side. Negative infinity, something goes on forever in the negative side. So if I put in something like 1,000 for x, or 1,000,000, or 2,000,000, or 1,000,000,000, the x squared, so 1,000 squared, and then 1,000 squared there, is you can't really tell what's happening, but I do know that my x squares are kind of dominating this fraction. So when I do long division, that kind of helps me see it better, because now I have 4 plus, oh, what is happening here, right? As x goes to infinity, we'll do plus or infinity first. So that means x could be 1,000, x could be 10,000, x could be 1,000,000, right? So as x changes from 1,000 to 1,000,000, what's happening to this quantity? 24 over x squared minus x minus 6. So what I want you to notice is that if x is 1,000,000 squared minus 1,000,000 minus 6, well, first of all, the minus 6 is not really going to affect 1,000,000 squared, right? You have 1,000,000 squared, that's a really huge number. Minus 6, that's not going to keep it from being a really huge number. So x squared, what about 1,000,000 squared minus 1,000,000? a million square is much, much, much larger than just a million. So even this minus x is still not going to affect it as much. So these are, what do I want to call them? I'm going to say not as dominant as x squared. So not as dominant as x squared. So really we're almost going to just focus on, and I'm going to highlight it, on the 24 over x squared. Because again, if you have a million in the grand scheme of things, a million squared minus 6, the minus 6 is not going to affect it that much. So what is this doing? So as x goes to infinity, or as x keeps getting larger, what's 24 over x squared doing? So think about, well, let's just put in a million in there. 24 divided by a million. Oops, that's not a million. A million squared. And even if you put this in your calculator, you might get an error because it will be way too small. So this is going to be very small, close to 0. So maybe start with 1,000 and then 10,000, and then you start seeing. So it goes close to 0. So as x goes to infinity, so therefore, as x goes to infinity, what is this quantity looking like? Y is looking like 4 plus a 24 over x squared is going to 0. From here. So y equals 4 is our horizontal asymptote. So long division helps us essentially be able to see, okay, as x goes to infinity, be able to isolate, instead of having something like x squared over x squared, where I have, okay, a million squared over a million squared, what is that doing? We can do the long division, and then I'm able to see, okay, so technically you can think of the quotient is going to be your horizontal asymptote. So now we have vertical asymptotes of, well, where are they? X equals 3 and x equals -2. And we have a horizontal asymptote, only one, at y equals 4. Or do we have another one? What happens as x goes to negative infinity? So what if x goes to negative infinity? Does it change? No, right? Because if you notice y equals 24 over x squared is going to be 24 over, so put in negative 1,000. Negative 1,000 squared, the square makes it positive, so you end up with the same asymptote. So horizontal asymptote is still y equals 4. Now if we wanted to graph it, now I need a lot more information. I need to know the y-intercepts, the x-intercepts, I need to know the domain, and I need to know the behavior around the asymptotes. So let's outline some steps for graphing rational functions. So the first thing that I'm going to want you to do is to factor completely. So first step is factor completely, if possible. Factor completely. The second step is we're going to find the domain. Remember, if you have a rational function for the domain, the denominator can't be 0. Which this is almost pretty much going to give us our vertical asymptotes. The third thing is find your intercepts. So how do you find y-intercept? So y-intercept is when x is 0. So set x equal to 0 and solve for y. X-intercept is when y is 0. So set y equal to 0 and solve for x. The fourth step is going to be to find your vertical asymptotes, which you'll already have them from the domain, from knowing that the denominator can't be 0, but do the test points. So from the denominator, and check test points to the right and the left of your asymptote to see to which infinity they're going, right? A vertical asymptote, you're either going to positive infinity or you're going to negative infinity. So you want to check that. And 5 is find your horizontal asymptotes. And so from here, we're going to do long division. And your quotient is the horizontal asymptote. Which for slant asymptotes, you still have to do the long division, but the quotient won't be a constant. So that's where your slant asymptote comes in. And then the last thing is sketch the graph, gathering all that information. Right, so we're going to sketch the graph of this one in another video. So try it on your own. So go ahead and follow the 6 steps to sketch the graph, or at least the first 5. So factor completely, which we already did. Find the domain. Find the y and x intercepts. We already found the vertical asymptotes. We already found the horizontal asymptotes. And then sketch the graph.